So let's read the problem number 4 of yesterday's contest. Contest number like 234. Starters 234's question number 4. So let's read the problem first. We don't need this right now. Binary construction. For a binary string s of length n, define a set f of s such that I plus j. So we have to make a set of I plus j and j are indices of elements in S. S is a binary string. Binary string has zeros and ones in the string. So we have to sum those indices where S of I is not equals to S of j. And here indices are started from 1 to n, and n is the length of the set. So we won't consider 0 as an index here because the indexes are given from 1 to n, and we have to make a set of those in some of those indexes where the element of the string is not equal. So what the question says is, let's see, we have a string, a binary string. So let's say we have 0, 1, 1. These are the elements. So I'm writing it like this, as equals to 0, 1, 1, 0, 1. So this is an example. So we have to make a set. This is a string, let's say, and we have to make a set. And we'll start the indexes from 1, 2, 3, 4, and 5. So now let's say 1 and 2 have two different elements. Unlike 2 and 3, they have same 1 and 1. So we can say that 1 and 2 can be summed and added to this set. So we'll add 1 and 2 and sum of 1 and 2 in the set, which will be 3. Similarly, we can choose two other indexes 1 and 3, and we can add sum here. 1 and 3 will be 3 plus 1, 4. And next we can do like 2 and 4. So we have to add these sums, like 2 and 4 is 6. And we have to keep adding, and we have to maximize the elements in this set. Let's see, find a binary string that maximizes the size of this. So what will be 2? We need a string. We have to print a string. Like we can see the output, we have to print a string. So the first thing which comes to my mind is to try different approaches right now. We haven't been given too many inputs. We don't have too many examples right here. So we'll try with n equals to 5, and we'll try to solve it. We'll try to get the maximum number of elements. So we'll see now. If n equals to 5, the string can be, so by observing in here, they have taken zeros first, and last one is added to the string. So this approach won't help us, but we can try once. We can assume that this might be the answer, and we can try to calculate. If we try with this string, there can be a set, and there are indexes. So what we'll do here is we'll make pairs of the elements which are different, like 1 and 5 is different, 2 and 5 is also different, 3 and 5, 4 and 5. So there are 4 elements which can be added to this set, and the sums are also different, like 5 and 1 6, 5 and 7 is 7, 5 and 2 and 7, 5 and 3 is 8, 5 and 4 is 9. So these sums are different. We can add this to a set because set should have unique values only. And then, but is this the right way to do it? Can we have another string of 5 digit where we can get more than 4 elements? So let's try something different. Let's try something like 0, 1, 0, 1, 0. 5 elements. This is the string. And let's make a set string. Let's make a set with these elements 1, 2, 3, 4, and 5. And now we can see that 1 and 2 is different. 2 and 3 is also different. But we'll first cover for 1. 1 and 2 is different. 1 and 4 is also different. Okay. 1 and 4 is different. And now if you see 2 and 3 is different. 2 and 5 is also different. Now 3 and 4 is also different. And 4 and 5 is also different. Okay. 3 and 4, 4 and 5. We can see 1, 2, 3, 4, 5, 6 elements in here. But is this the right way to do it? Because here we can see 4 plus 1 will be 5 and 2 plus 3 is also 5. So if we add a sum to this set, only one 5 will be added. So these are like the similar case. So we can cancel 1. 1 and 2 is 3, so 3 can't be a sum. 2 and 3 is okay. And still we have one more. 4 and 3 is 7, but pi and 2 is also 7. So we can't add duplicates to a set. So we have to cancel one more case. Now we are left with 1, 2, 3, and 4. Again, 4 elements. So we can see that by this way, it won't work. And this way would also won't work. If we want more elements, we should do something else. So now we can observe that the sum is mostly 3 here, maybe 5 here, maybe 7 here, maybe 9 here. But can the sum be like 4? No, like can it be 4? Can it be 6? If we find more sums, we can find more elements, more different sums. So sum can be 1, 2, 3, 4, 5. These are the indexes. What can be the sums? What can be the different sums? Let's calculate that. 1 and 2 can be 3. 1 and 3 can be 4. 1 and 4 can be 5. 1 and 5 can be 6. Other sums which we can calculate but are different from this are like 2 and 5 can be 7. 3 and 5 can be 8. Furthermore, we can calculate 9 also, 4 and 5. So we know that we have to take more and more elements, like more and more different sums. So how would we do that? Firstly, how did we calculate 3? So we took 1 and 2, then we took 1 and 3, then we took 1 and 4, and then we took 1 and 5 to calculate 6. And then we took 2 and 5 to calculate 7, 8, 9. So what can we do here? We can make a string with, so we have to take 1 and 2. So 1 and 2 should be different. So that we can take 1 and 2. And 1 and 3 can also be different. 1 and 4 can also be different. Now we can see that if we take 1 and 5 different, we have to take 5 as 0, which we have covered already. We only get 4 cases in that case. So we have to find more than 4. So we will take something different in here. We'll try this once. So you will find that in this particular case, 1, 2, 3, 4, and 5. So if we make pairs in here and we add it to a set, this is the set. If we make pairs, 1, 2 is different, 1 and 3 is also different, 1 and 4 is also different. like it's over. And now 2 and 5. 2 and 5 is different. 3 and 5 is also different. 4 and 5 is also different. We get 6 different sums. So we can get 6 different elements in the set. This can be an optimal method because we have got more than 4. So what can we do else? We can try we can try more combinations. We can do like we can put 1 in here. But if we put 1 here, we can see that we have covered that case in this one. We still get 4 because we get the repeated number of repeated sums, which we can't add in a set. So the sums we could have got were these. We just don't get 6 here. As you can see, 5 and 1 are same, so we can't get 6. 4 and 2 is also same. So on excluding 6, we still got 6 other sums. This is one of the maximum cases. This is most optimal case. Like if we keep trying different permutations, different combinations of zeros and ones in the string, we can find different values, but we can't get more than 6 elements in the string. So this was my approach during solving this problem because I tried too many strings and I have got to the conclusion that only this one case would work here. Now, there's one more edge case which we should consider, which is given in the input, which is 2. So in 2, so how can we print this one? So firstly, we will make a string, which is of n length, and let's consider 5. We'll make a string of 5 zeros. Then we'll make the first and last element as 1, and we'll make another string. This is our answer because we will get maximum number of elements here. We can choose anything else. We can do this, but we'll still get the same number of elements before as we got before, or maybe less, or maybe not more than 6. But this is my observation. This approach came after I have tried too many different strings. Now this is what we print for n is greater than 2. But what if n is equals to 2? If n is equals to 2, we have to make a string which is of length 2. Maybe we'll do this, and then if by our approach we'll make the first element and the last element as 1. So this won't work because there are no different elements, and the answer should be 1 or 1 0 or 0 1. So for this test case, this particular test case will handle it separately. So I can see this is the code. So we can see here, this is the test case loop. N is taken as input. We'll make a string of n digits with all zeros, n length with all zeros, and then we'll see if n is greater than 2. If for any n greater than 2, if we make the zeroth element and the last element 1, and we return the string like this, the answer will be right for us. But if n is equals to 2, and n can't be 1 or something because n is given as greater than 2, greater than or equal to 2. So in the case where n is equals to 2, we'll make the first element or the last element 0, like this. Either this or either this. Both of them will be accepted because we are given here like all will be accepted if multiple answers exist. So we can see that there's only one case here. We can add only one element to the string. But if we take 1 and 1 or 0 and 0, both of the elements are same and we can't add any element to our set. We have to make sums of the indices, but we can't do it because both of the elements are same. So in this way, I solved this problem. I took n as input, and I just made first and the last element as 1, and this was submitted like in the first run. I can see the accuracy is very low. I don't know why, but yeah, this was the approach. Thank you.